Now we're going to take a look at continuity. On the next double page, you're going to take your ruler and you're just going to leave a little bit more space in the margin and tear it all the way down. A little more space more than the margin, tear it all the way down. Once you've done that, you're going to make tabs. Alright, the first one is going to be at the margin, tear it all the way down. I'm going to make a total of 5 tabs, 2 lines each starting from the bottom. I make a mistake in mine, I count 10 lines, but you count 8, right, because I end up fixing it later. Count 8, tear it across, and then down. And then 2 lines underneath that, tear it across, and then down. 2 lines underneath that, tear it across, and then down. So you're making tabs and it looks like this. Alright, and you're going to have a total of 5. So 2 down, all the way down. Alright, then we're going to just label this. So continuity is the title, and then on the side we're going to write types of discontinuities. And those are jump, point, essential, removable, and the last one is not type of discontinuity, but it's just property of continuity. Properties of continuity. You're gonna need to know that. Alright, so when you're talking about continuity, there are 3 questions you need to ask. Number 1, is f of a defined? Number 2, does the limit exist? And number 3, is the limit equal to f of a? Just gonna flip through the pages to make sure that you've labeled them correctly. Alright, so let's talk about continuity. In order for a function to be continuous, it must satisfy all 3 questions. Alright, so let's take a look at them. Is f of a defined? What does that mean? When you plug in the number that x is approaching, do you get an output? When you plug in a number that x is approaching, do you get an output? If you do, then f of a is defined. This is a listening check. This is a listening check. Go ahead and shade in the word approaching above. Shade in the word approaching above. Number 2, does the limit exist? What does that mean? Is the limit as x approaches from the left equal to the limit as x approaches from the right? In other words, is the left limit equal to the right limit? Lastly, number 3, is the limit equal to f of a? What does that mean? Are your answers that you answered in question 1 and 2 above equal to one another? If you answered yes to all 3 questions, then the function is continuous. If you answered yes to all 3 questions, then the function is continuous. So let's take a look at some examples. If f of x is 4x squared minus 2x when x is less than 3, and 10x minus 1 when x is equal to 3, and 30 when x is greater than 3, is this function continuous at x equals 3? So again, remember, it must satisfy all 3 conditions. So let's take a look at each condition one at a time. So in condition 1, is f of a defined? Meaning, at the point x equals 3, when you plug it in, is it defined? Well, where is it on the graph that x equals 3? According to the graph, it's when 10x minus 1. That is the equation that you use. So condition 1, we're going to plug in 3 where 10x minus 1 is, because that's the only part in the graph where it's defined. So 10, 3 minus 1, which is 30 minus 1, which is 29. So it is defined. I get an output. Does the limit exist? So looking at the second condition, we need to find the left and right hand limits. So does the limit exist? The limit as x approaches 3 from the left. Now, if it's coming from the left, it's coming from like 2, so real close to 3 would be like 2.9999, which is the first one, which is 4x squared minus 2x. And if I pick a value really close to 3, so let me pick 2.99999, and you can really pick whatever you want, just really close to 3. And then I plug that in the function. This is a listening check. This is a listening check. Underline 29. Underline 29. And use my calculator. I am going to get 30. The limit as x approaches 3 from the right hand side, notice the equation for that is just equal to 30, so there's nothing to plug in, is going to be 30. Okay, Now look at the left-hand limit. Is it the same as the right? Yes, it is. Therefore, the limit as x approaches 3 of f of x is equal to 30. So yes, the limit exists, so it satisfies the second condition. Checking for the third condition. Is f of 3 equal to the limit as x approaches 3? It is not, because we got, for number 1, we got 29, and then we got 30 was the limit. So 29 is not equal to 30, therefore its function is not continuous at the point x equals 3. This is a listening check, this is a listening check. Go ahead and box. It is not continuous. Put a box around, it is not continuous. Take a look at one more example. Suppose f of x is x squared plus 3x plus 5 when x is less than 1, and 6x plus 3 when x is greater or equal to 1. Is this function continuous at x equals 1? So again, it must satisfy all three conditions in order to be continuous. So looking at the first condition, when we plug in 1, do we get an output? Is f of a defined? So if f of 1 defined. So when x is 1, which equation are we going to use? We're going to use the second one because that's greater than or equal to 1. So when f is equal to 1, 6x plus 3 is the equation that we're using. And then plugging in 1, we would get 6 times 1 plus 3, which is 9. So yes, the function is defined at f of 1. Therefore, number 1 is okay. Does the limit exist? So again, we need to look at the left is equal to the right-hand limit. So condition 2, as the limit as x approaches 1 from the left-hand side, which equation are we using? Well, from the left-hand side is numbers less than 1. So we'll use the first equation, so x squared plus 3x plus 5. And then we're going to plug in values that are really close to 1 but not equal to 1. So close to 1 would be 0.999999. And again, plugging it into a calculator, we're going to get 9. This is a listening check. This is a listening check. Go ahead and color in x equals 1, where it says continuous at x equals 1. Color in x equals 1 alone. The limit as x approaches 1 from the right-hand side, so which equation are we using? So there's a number bigger than 1, so we're using 6x plus 3. And we're plugging in numbers really close to 1, so 1.00001. We'll get 9. So the limit, as we can now say, the limit as x approaches 1, because the left and the right are both equal to 1, it exists, of f of x is equal to 9. So the first two conditions have been satisfied, and we must satisfy the third one. Is f of a defined, and is it equal to the limit? So looking at that, we both got 9 for both answers, so therefore the third condition is satisfied. Therefore the function f of x is continuous at the point x equals 1. In our next video, we'll take a look at the types of discontinuity. You know the drill. Let's practice.